Hi, I'm Sarah Morgan and welcome to my presentation on advancing circadian lighting measurement, establishing a Vancouver-based test facility leveraging quantum dot precision. Over the past decade, many lighting companies have approached Nanolit, which I founded, with questions about circadian lighting and biological metrics. What we kept seeing was not a commercial issue, but a measurement gap. Without accredited facilities, informal guidance became the default, which isn't sustainable as the industry moves toward CIE, BIPM biological light standards. These repeated requests across companies and even competitors made it clear that we need a formal, accessible, accredited circadian measurement capability in Western North America. And when I say accredited, I'm referring to ISO 17025, validated testing, where the calibration pathways, uncertainty budgets, and quality systems have been independently verified, so results are traceable and recognized across laboratories. That is the context for this work. You'll see a QR code throughout the presentation linked to a short questionnaire, and we welcome your insights. I'll also be able to send you a summary of this presentation through that link, and if we have time, we can review the results of that at the end of this presentation. So this initiative supports the CORM-CIE mission by strengthening measurement science and helping advance biologically based lighting standards. Our work in circadian lighting, displays, and quantum dot spectral engineering comes together at a key moment for photobiological metrology, as standards bodies and industry look for validated ways to measure circadian impact. Establishing a regional accredited facility is a timely step in that direction. And as Dr. Jamie Zeitzer notes, our understanding of light and health continues to evolve, and our measurement tools must evolve with it. As I mentioned, I'm the founder of Nanolit Technologies, and we've developed revolutionary circadian rhythm lighting systems. Our cutting-edge circadian lighting software was recognized by the Illuminating Engineering Society, and we're an innovative technology provider and strategic partner in the development of the WELL and LEED lighting standards. We're fortunate to be supported by advisors with deep experience across science, engineering, and technology commercialization, spanning technology management, microbiology and immunology, nanotechnology, chemistry, physics, and advanced manufacturing. Their backgrounds include leading university innovation programs, building award-winning deep tech companies, and guiding major aerospace initiatives. This collective expertise strengthens the development of the facility and its measurement capabilities. We also formally joined Simon Fraser University Venture Labs Perigo program on November 1st, 2025, which adds further structure and support to this work. My first migraine struck at age 11, outdoors in blinding sun. Family stress and impending pressure at school collided in a perfect neurological storm. The pain was unbearable and felt like someone had hit me on the back of the head with a sledgehammer. I fell to the ground and spent the next 12 hours in the dark with a wet towel over my head. Fortunately, my dad, who was a lifelong migraine sufferer, understood what was going on and knew how to handle it. The nausea was debilitating. But at 14, I discovered industrial design and lighting, eventually completing my master's thesis on light and biomimicry. This personal connection led me to found Nanolit Technologies, developing quantum dot lighting that supports neurological health, particularly for the 75% of neurodivergent people with light sensitivity. Not long ago, I visited a lighting booth at a furniture trade show, and it was advertising healthy lighting and circadian effective lighting. When I asked salespeople at the booth what those claims were referring to, the vendor told me to contact a scientist at their parent company because they couldn't explain the metrics themselves. I've seen this happen many times, and it shows a bigger issue across the industry. Around the world, there is growing movement toward using shared biology-based light metrics like melanopic EDI and the CIE S026 system. At the same time, governments and ESG groups are starting to expect real evidence behind any health-related claims about lighting. Companies can't rely on vague or unverified marketing statements anymore. From recent surveys, including one in Toronto, it's clear that many people in the lighting field are still unsure about how to measure circadian effects or which numbers to use. So although the science and technology have advanced, the testing and measurement systems needed to support them haven't fully caught up, and that gap is a major reason for today's discussion. Customer confusion is not accidental. It is shaped but by mainstream voices who oversimplify the biology of light and sleep. Many practitioners and companies reference these popular sources because accredited circadian measurement tools do not yet exist. This is not a commercial problem, it is a measurement problem. There are facilities that can run parts of these tests, but they're not easily accessible. For most companies in Western North America, getting circadian or melanopic measurements means shipping products long distances, waiting weeks for results, and dealing with high costs and complex logistics. Because these measurements require different methods than traditional lighting tests, the lack of a nearby option creates a real gap between what the science can measure and what companies can practically validate. That gap makes it harder to support accurate claims and slows product development with longer timelines and higher costs. I know that many at CIE and CORM have faced similar challenges. As many of you know, measuring biological light isn't as straightforward as measuring standard lighting. These measurements often need different tools, different calibration steps, and clearer ways to handle uncertainty. Across the community, uncertainty ranges and reference materials for circadian metrics are still taking shape. Without common test methods, it's hard for labs to compare results with the precision needed for standards work. This isn't about the science being unclear, it's simply a sign that the infrastructure is still catching up. And when that happens, standards development naturally slows. Committees need consistent data and repeatable methods before a biological metric can move from research into full adoption. The slower uptake of CIE-aligned biological metrics reflects this practical challenge, not a lack of agreement. So this proposed facility will bring together advanced instrumentation with SI traceability, modelling tools that link spectral data to biological responses, and expertise to help interpret those results for real-world applications. It also provides accredited testing so manufacturers can access verified performance data for regulatory and reporting needs. This integrated approach reflects the gaps identified in the Toronto survey and what we expect to see echoed in Vancouver. The facility will be designed to support the full measurement ecosystem, from core metrology through practical applications in lighting, displays, and human-centric design. As part of this effort, we are adding a CTO with 20-plus years of experience in semiconductor and optics, with deep experience in solid-state lighting, optoelectronics, and spectral system design. This PhD-level engineer has led R&D in high-power LED and UV visible systems and worked extensively on calibration and device characterization in both manufacturing and metrology environments. This expertise will enhance our measurement infrastructure, instrumentation development, and traceability workflows. Our focus is not on a pass-fail criteria, but to iterate and collaborate with lighting manufacturers to deliver optimal, personalised lighting. Quantum dot technology gives us stable, precise and tunable spectral output, which we'll use in the facility to create controlled reference sources. These sources allow for repeatable spectra that support circadian photometry, colour measurement and cross-domain validation across lighting, displays and biological response models. We introduced quantum dot lighting in Canada in 2017 and later launched a scalable product that saw strong early uptake. That experience showed us that once precise spectral tools reach the market, manufacturers immediately look for reliable ways to measure and validate them, and the measurement infrastructure just hasn't kept pace. With Nanosys' advisement, they provide us the materials and expertise needed to integrate this technology into the facility. And with that, I'd like to introduce Jeff Urek from Nanosys to speak about their capabilities and the broader role quantum dots can play in emerging measurement needs.